Today is going to be an introduction to complex numbers. So, this is going to be something that is fairly new and maybe totally new for most of you guys. Um, what I want to do is introduce it and just give a little bit of a context to it. And start it with some things that I think we have seen before. So, before I get into complex numbers, I'm just going to pull up in my notes here. Again, I'm in Notability and going into my 490, 491 folder. I'm just going to pull up a blank sheet and do a couple of example problems. And this would be stuff that we probably have done in our algebra classes before to some extent. So if we wanted to, let's say, solve the quadratic equation 3x squared plus 2x minus 2 is equal to 0, there are a few things that we could do to try and solve this. We could try and factor it. That would be a really good idea. The problem is that, my advice is try and factor it for 10 seconds first if you're trying to solve a quadratic. I think I said 10 seconds. I usually give it 20 seconds, especially when we have a leading coefficient other than 1. But if I do 3x and x, and I try different combinations of 2 and 1, that's going to give us 3x and 2x. I can't get 2x in the middle. So if I switch them and made it 1 and 2, that's going to give us 6x and 1x. It boils down to I can't factor that, okay? And if it takes you too long, we can always use the quadratic formula. So the quadratic formula is that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, again, this is just an introduction into what we're going to be doing. Your homework tonight is not going to cover the quadratic formula or do problems to this, but I want to give you an idea as to why we are doing complex numbers. If we wanted to solve this quadratic equation, the a value is 3, and the b value is 2, and the c value is -2, and I plug those into the quadratic formula. So here we go. So x is going to equal the opposite of b, so the opposite of 2, plus or minus the square root of b squared, so it's 2 squared, which is 4, minus 4 times a times c, c is -2, don't forget, all over 2a, so 2 times 3 is 6. And I'm going to continue to simplify this, so I have -2 plus or minus the square root of, this is going to be 4 plus 24 or 28. Okay, don't forget we have double negative in there. So when we multiply those, we get 24 plus the original 4 gives us 28 all over 6. And I know I'm going a little quickly, so don't write frantically because I'm going to go to our other note sheet, which will be laid out for you. But we could simplify this as well. We've done these factor trees like this here. So that could be 2 and 14, and that could be 2 and 7. So that comes out to be 2 root 7. And so my x is -2 plus or minus 2 root 7 over 6. And I could, cancel it 2 here, here, and here. And so our final answer would be -1, plus or minus the square root of 7 over 3. So we would have two answers, -1 plus root 7 over 3 and -1 minus root 7 over 3. All right, well, that would be a problem that we right now have all the skills to solve. But I'm going to change the problem ever so slightly and do it again. So I'm going to solve the quadratic 3x squared plus 2x plus 2 is equal to 0. And I'm going to do the same process. Now I'm going to go even a little bit more quickly because we just did that. And you don't necessarily need to write this down. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get x equals -2 plus or minus. Now, here's where it changes. I have inside here, that's a really important number. I have to do the multiplication first. 4 times 3 times 2 is 24. And 4 minus 24 is -20 over 6. So you see the difference between this one and the previous one. Before I had 28 underneath the square roots. Now I have -20 underneath the square root. And when that number is negative, that means that there are no real solutions. And in the past, we may have stopped right here because there are no real solutions. However, there are complex solutions. So we're going to introduce complex numbers and figure out we can actually solve this. By the end of class today, we should be able to figure out how to solve that. All right, so let's go to complex numbers then. So this you should start writing down. I'm going to open the Unit 2 notes, and if you didn't download those yet, they are found in Schoology. So put them from Schoology into Notability. And in the Unit 2 notes, we are talking about complex numbers. So first thing is, I know it says what comprises the set of complex numbers. I'm just going to state what is a complex number. Okay, so a complex number is of the form a plus b I. And I wrote that I in cursive. It typically is written or italicized either way. It typically is written that way because that stands for the imaginary part of the complex number. So a complex number is of the form a plus bi. I just lost my share there. Sorry about that. Is of the form a plus bi, where a and b are real numbers. So something like just this right here, 3 minus 2i. Okay, that's a complex number. 3 is a real number, okay, and -2 is a real number. So like those are your a and b. And so then the first part, this is just a real number, and the second part makes up an imaginary part, okay, that I stands for something. I'll introduce that in just a second, but they all are of the form a plus bi. So that's what standard form any complex number would be written as. So the I is given a value. I is the square root of -1. So it's not a variable. And that's important. It has a value. Okay, like pi has a value. Okay, I has a value. It is the square root of -1. So using a little algebra, if we were to square both sides of that equation, the left side becomes I squared, and the square root of -1 squared becomes -1. So I squared is -1. So these two rules are ultra important. Okay, that I is the square root of -1, and that I squared equals -1. And we're going to do first just some operations of that. Now we can get higher degrees of I. We could find I to the third and I to the fourth and I to the fifth and so on. We'll do that at a different time. Okay, so we can take different powers of I to any degree that we want to. But for now, we're simply going to do some operations using I. So even though I said I is not a variable, and it's not, it doesn't vary, it follows algebraic principles like variables. So for example, when we are trying to simplify this, I'm going to distribute 3i, I'm going to do 3i times 5 and 3i times 6i. So that's going to give me 15i plus 18i squared. So just like if it was 3x and it was 5 plus 6x, it would be of similar process. Okay, so it follows the same rules. Now remember, keep in mind, I squared means something. I'll come back to that. But I'm just going to distribute the negative 2 over here. So that's going to be minus 8i and plus 6. Okay, so that's our first step, is to distribute, just like we would in simplifying any other algebraic expression. Now, we have to remember that I squared is negative 1. So this is negative 18. So I now have 15i minus 8i would be 7i minus 18 plus 6. Okay, so those two became that. And the minus 18 came from here. And the plus 6, of course, is this guy. And then we want to combine the negative 18 and 6. So it finally simplifies to 7i minus 12. All right, let's do part B. Now, remember that I is the square root of negative 1. So when you have the square root of negative 9, that is equal to 3i. And I'll show you why. Remember our old factor trees? We could write that as the square root of 9 times the square root of negative 1. We could split that. And the square root of 9 is 3. And the square root of negative 1 is I. So it equals 3i. So I'm just going to rewrite it as 3i. And I'm going to solve then 4 times 3i plus 2 minus 4i times 3 minus I. So I just rewrote it, but I rewrote that as 3i. It's just easier for me to visualize. And now I'm going to follow the same steps I did in the previous problem, distribute the 4 and distribute the negative 4i. All right, so let's go with that. 4 times 3, that's going to be 12i plus 8 minus 12i plus 4i squared. Remember, I squared is negative 1. So that is a negative 4, because it's 4 times negative 1. So when I combine 12i and negative 12i, I get 0i. They cancel out. And 8 minus 4 is 4. So our answer is just 4. So I just combined my like terms there. All right, another operation. If you had 3 minus 2x and 2 minus 4x, you would FOIL that. We're going to do the same thing. We're going to FOIL this. So when we FOIL this, 3 times 2 is 6. On the outside, I get negative 12i. On the inside, we have negative 4i. And then the last, negative 2i times negative 4i is plus 8i squared. And remembering that that is then going to become a negative 8, which I will use in my next step. So I have 6 minus 8. So 6 minus 8 is negative 2. And then negative 12i minus 4i is negative 16i. And that is our answer. Now notice that you can write your complex number either way, with the real part first and the imaginary part second. It also, over here, I wrote the imaginary part first and the real part second. It can be written that way. It does mean the same thing, but it really would be best to keep it in the general form of a plus bi. So when we get down to here, probably would be best 2, I'm going to move this guy up a little bit and write that as negative 12 plus 7i, so that it's in that standard form that we talked about for a complex number. Okay? So we talked about what a complex number is. We talked about it, that I is the square root of negative 1, and therefore, of course, I squared is negative 1. And we did some operations on that. I am going to do the next part, which is also that what to do when imaginary number is in the denominator of a fraction. The problem is, remember that I is the square root of negative 1, and we can't leave a radical in the denominator. So this really has a radical in the denominator. So I need to get rid of that. Well, what I could do is I could multiply the top and bottom by I. I could multiply by 4i also, but it's easier just to multiply by I because watch what happens. The top gives us negative 12i, and the bottom is 4i squared. Well, remember, I squared is negative 1. So that means now our denominator is negative 4. So we have negative 12i over negative 4, which we can simplify to just 3i. So we can't leave our answer with an I in the denominator. Let's do the next one. So we have 5i in the bottom, so I'm going to multiply the top and bottom by I. Now on the top, be careful. I have to distribute this here. So that's going to be 3i minus 2i squared over 5i squared. Knowing that I squared is negative 1 here and here, my top becomes plus 2 and my bottom becomes minus or negative 5. So my top is going to be plus 2, which I'm going to write as 2 plus 3i. So this is your plus 2. And then I just switched the order so that it was in that standard form. And the bottom is negative 5. So we can pull that negative out front. And our answer is the opposite of 2 plus 3i over 5. All right, last type of problem. See, this is different because here we have 3 plus I on the bottom. I can't just multiply by I. Because here's what would happen. Let me show you just quickly. Like we did before, I just multiply by I. But if I multiply the bottom by I, the top would be fine. But on the bottom, I have to distribute. I would get 3i plus I squared. This would become negative 1, but I still would have an I in the denominator. So if I have a plus or minus situation on the bottom, if I'm adding or subtracting, I can't just multiply by I. What I need to do is multiply by what's called the complex conjugate. Complex conjugate. That's a really fancy way of saying rewrite this number, but change that sign. If it's a minus, make it a plus. If it's a plus, make it a minus. So the complex conjugate for here is 3 minus I. I'm going to do that on the top and the bottom. And just to show you on the next one, the complex conjugate, I'm going to rewrite this and just change that sign. Is going to be I plus 4. Okay, but I'll do them one at a time, of course. So to do F, I'm going to distribute the 2. So I get 6 minus 2i. And on the bottom, I have to FOIL. I get 9 minus 3i plus 3i. Those are going to cancel. That's why we changed that sign in there. And then minus I squared. So this is good news because if we use the complex conjugate, the two middle terms cancel out. The last term will have an I squared. That's going to become positive 1 because it's minus negative 1. So I have the top is 6 minus 2i, and the bottom is 9 plus 1, or 10. And now those are all even, so I should simplify that and divide them all by 2. So I get 3 minus I over 5, and that would be our final answer. So I'll do the last one, G. So here I'm going to FOIL. I have to FOIL both the top and the bottom. So when I FOIL the top, I times I, that's going to be I squared plus 4i minus I minus 4 divided by, the bottom is going to be I squared plus 4i minus 4i minus 16. So I squared is negative 1, so that's going to be negative 1 minus 4, which is negative 5. And then 4i minus I is 3i. So the top or numerator is negative 5 plus 3i. In the denominator, the two middle terms cancel, which is good. I have I squared, which is negative 1, minus 16, which is negative 17. So that would be, our answer doesn't simplify at all. We could move the negative up top, and you could write that as, distributing the negative 5 minus 3i over 17. Multiplying top and bottom by negative 1. All right, so we have our what a complex number is. We did some operations of that, and then we did rationalizing the denominator. So to get back to where we started, remember, we left this problem right here. Well, now we know that the square root of negative 20, I could do a factor tree. I'll write that down here. That's going to be, I could split that into the square root of 2 times the square root of 10 times the square root of negative 1. And then write that as 2 root 5 I. The I is not underneath the square root, by the way. So the square root of negative 20 is 2 root 5 I. So I'm going to go back up here. And I'm going to say, all right, I have negative 2 plus or minus 2 root 5 I all over 6. I got to get rid of this junk because I'm running out of space. So I have, then I can divide all of these by 2. And so my final answer would be then x is equal to negative 1 plus or minus the square root of 5 I over 3. So we're headed towards this idea with the quadratics. For today, we're just going to be working on doing these operations with I.